Okay, so now we're going to look into the ZTNA connector template. So ZTNA connector is a virtual appliance which is available to be deployed in hypervisors such as ESX, Hyper-V, KVM for the on-prem data centers, as well as in the cloud. For the cloud, the templates are available in the marketplace. You can fetch from there and deploy it. For the on-prem deployment of ZTNA connectors, we have uh, individual templates depending upon your deployment model, whether it's a one arm or two arm, available for getting for available to download and deploy it. Now, how to get these templates is the templates are available in our support portal, Palo Alto support portal, support.paloaltonetworks.com. And under updates, you have software updates. If you search for ZTNA, you will see the three major hypervisors for which the images are officially available in the support portal. So once you determine which hypervisor you're going to roll out your ZTNA connector, you can pick up whether you need a one arm or a two arm. So it's a one arm and a two arm versions of ZTNA connector template. And if you notice here, the only difference between these four OVAs is one is a one NIC, other one is two NIC. One NIC is a one arm, two NIC is a two arm. So depending on what you require, you fetch the respective image and preferably try to use the latest published image. Here, this release is B9 and this release is B8. If you choose to deploy B8, there is the ZTNA connector in Startup Cloud Manager allows you to upgrade it to B9. So it's not a big problem. But however, depending on your policy, I mean, depending on what you need, you can select one of these images. But one thing to remember is once you choose to use a one-arm deployment, if you want to migrate to two-arm, it's not possible. So you need to be very uh, thoughtful and very, precise at what image will work for you. You need to design it and implement it accordingly. Okay. Application and connector address pool configuration. So this configuration is available under the infrastructure settings for Prisma Access under the in Startup Cloud Manager. So if you notice here, you have a specific line item called ZTNA connector IP blocks, which is the application IP block and the connector IP block. So as I mentioned to you earlier, if you are considering to use Prisma Access browser or explicit proxy, try to avoid these subnets. You can use anything outside this range. And if you ask me these subnets, how does it impact you? So these IPs are anycast IPs for the apps from the application IP pool, and the connector block chunks are located per individual connector. So does the data center or the cloud infrastructure need to learn about these IPs? These IPs are not exposed. We don't need to learn about it. It is used within the Prisma Access infrastructure for its internal communication, and the mobile users would be connecting to the private apps through one of the virtual IPs, which is from the Anycast IP for the FQDN app that will be assigned to it from the application IP pool for the respective private app, and the IP would be provided by the, the, the connectivity mechanism, either it is a GP or RN or EP, would be resolving the FQDN to an IP, virtual IP from the Anycast IP from this pool. So that is the only device which will be learning about this IP, whereas these IPs are not required, will not be learned by any of your the app server or as well as within the data center. But however, this belongs to your tenant, and you need to size it as per the requirements, the number of apps you're going to connect, the number of connectors you're going to deploy. You can work with the solution team of Palo Alto Networks and then plan for these subnets accordingly. Okay, but this IP should be unique and not overlap with all the constraints I discussed in the previous slide. Okay, creating the connector group. So the connector group is the first object we create within the ZTNA solution before we deploy the connector. The UI for Startup Cloud Manager had a recent upgrade, and this is the path you need to follow. You need to go to configuration, ZTNA connector. After you enable the ZTNA connector groups and create your connector group. Alternatively, if you have not created your connector group and you are straight gone to connectors, then it will allow you to create a connector group from the when you're creating your new connector. So there are two ways to create the connector group. And under the connector group, you have an option to preserve user ID or auto scale. So these are two very important options. This depends upon how you want to deploy your ZTNA solution. If you have a Pan OS, Palo Alto, firewall on-prem, where you want to distribute the user IDs and apply user-based rule policies in the firewall to give access to the apps, then you need to preserve the user ID. But if you don't have a Palo Alto firewall, then you don't need this. This option is to be unchecked. Okay, and then the second one is auto scale, which is applicable for your deployment in the cloud, especially for AWS and Azure, where the connector group will onboard and onboard and remove the connectors based on your network throughput and usage, depending on how you configured your templates in the cloud platform. Within the ZTNA connector group, we have the list of connectors. So in this screen, we have. Let me see if I have a pointer. Okay, so in this one, you see here that you have a fabric IP, which is the connector block chunks, which I discussed in the previous slide, that will be assigned per connector. This is the version of the connector. This is the location of the connector. And we can alternate. We have action window available here if you want to choose. This is a token and a secret key for the connector. All right. So these are the list of connectors within the connector group. It's a quick view of what is there inside the group. So each connector group can have up to 4 connectors per location. Okay, so we have a connector group. That connector group can have 4 connectors defined, and a location can have multiple connector groups configured depending upon how you want to design your ZTNA solution. If you have more questions about the sizing and designing, it would be best if you could reach out to the solutioning team who are the experts in advising how to rightly size it, so that you don't need to keep on changing your design, and get it set proper so that it can fit your business requirements. The ZTNA connector group has IP subnet, FQDN target, and wildcard target. These are the 3 ways by which the apps can be accessed, and it is per group. And whichever connector is participating in the group will be able to provide access to these targets. Okay. Creating a connector. Creating the connector, as I mentioned to you, this is the plus icon where we can create a connector group while we are onboarding a connector. Again, so we have a menu called Create Connector under the ZTNA connectors, where we can create a new connector. It's just a name we have to create, and there's this create button available for you to click and save it. So once you have this connector created, we have something called a token, which comprises of key and secret. Okay, consider this to be like a passport and a boarding pass. So when you onboard a connector, when you create a new connector, the connector, when it first initiates the connection to PA controller, so it needs to identify itself, like which tenant it needs to connect to. So that is your key, and then and the secret is provided along with the key, so that it will measure from where you're trying to connect and then onboard you to the nearest location within the Prisma Access infrastructure, and onboard the connector as well as connect to it and build the configuration, everything. So this is a core component of the by which the individual connector is identifies itself to the Prisma Access controller and onboards itself into that respective controller. This token, if once you generate it, is only valid for 72 hours. We cannot reuse it. The only situation where the token and key and secret is reusable is in auto scaling deployment, where the AWS and Azure auto scale groups will onboard and remove the connectors according to the network throughput and scaling requirements. Okay, so that time the keys will be reused. But aside to that, once you generate it, you have 72 hours to bring your connector online. And for some technical reason you cannot connect to the PA controller and bring the connector online, then you need to regenerate or you need to create a new token or you need to create a new connector. Delete the previous connector and create a new connector. Okay. ZTNA connector installation for in the ESX platform. Okay. Charles, you're there?
Indeed, I am. Yes.
Yeah. So Charles, we take a break at 10:30 my local time.
Sure.
Singapore. Okay, for 10 minutes so that we can have some uh, short break and then we can reconvene. Okay, so we are in another 20 minutes. We will cover the topics in the slide.
Yeah. Whenever you want is perfectly fine. Just let me know.
Okay.
Of course.
So here, so far, just to recap on the onboarding journey of the ZTNA connector, we have an app pool to be defined, which is part of your planning process. As I mentioned, we need to take the constraints into consideration. We create a connector group. We onboard the connector. We create the connector, and then we have a token in our hand ready to build the connector. Okay, so once we have it, we determine which platform we are going to do it. The token and the secret which we generated will be configured as part of the template to deploy the connector, and we'll have a short video here that shows you how the connector is deployed in ESX platform. Depending on the hypervisor, it will be different. So I just chosen ESX, which is a very common hypervisor used for deployment. So we select the image, we assign the network. It's a 2-arm deployment. The disk must be thick sized. The token, key, and secret is provided. Once the token is used, it's useless. So it will it cannot be used to deploy another connector. So we select all the settings and then we finish it. We verify it so that we don't make any mistakes. IP can be configured as static or DHCP depending on your requirements. Each one has its own advantage and disadvantage. So you can, whatever applies to your organization, because this connector is going to sit inside the data center or the cloud, you can follow the standard. So the connector gets created in your hypervisor. It takes a few minutes for this process to complete, and then the connector would boot up, and during the initial boot up, it will apply those token keys and secret and start onboarding itself by connecting to the PA controller. This is an access controller. So here the connector is booted up. We are viewing this from the console. There's a default credentials available for the connector, which is available in our tech docs, and with that you can log in during the first boot up. Okay, so as I mentioned to you, after that it was pretty straightforward. You extract the OVA file, you configure the parameters you need, the port, the interface, the disk size, the token key and secret, and then once you boot up, you will just have the screen available. And in order to log in, the password is available in this link. For the element admin is the username. You can log into the connector. So this is the first phase of the deployment of a connector. And after this, whatever you see inside the connector applies to all the platforms, whichever you choose to consider for your deployment. So once I log in into the connector with the initial default username and password, this is a common screen we look at. So what this is trying to tell us is the ports have not yet been initialized. So when you look at the dump overview output, we don't see any physical interfaces, port 1 or port 2, visible under the dump overview as an operational interface. Okay, and we don't see any mix certificate or a claim certificate, not present. So this is the like it's in a cradle state, the connector. It's yet to connect to the PA controller and configure itself and onboard. So nothing to panic. So once you see this, you should understand that I'm in this phase of the deployment of the connector. These are the things which are supposed to happen, and these are the things which it is currently trying to do. So currently it's trying to initialize its interface, and after the interface is initialized, immediately you'll see it listed under operational interface with an IP address. Okay, so this is the very important step. So if there is any problem in your underlying hardware of the hypervisor, or if the networks are not being read by the connector, you won't see this interface. And in that case, you can open a support ticket and you can work out on troubleshooting this problem. So it works. It's plug and play. The moment the connector is onboarded, the powered up, you should see this interface. So at this point, interface are initialized, but we do not have a certificate present, and we do not have any connectivity to the PA controller. So this is now we are moving from the interface initialization to the PA controller connectivity for verifying our tokens, which identify us within the Prisma Access, which tenant we need to connect to, and then receiving the respective certificates, and then orchestration of the ZTNA connector, which involves the configuring the tunnels, and the tunnels get built up based on your location, and then the tunnels get created and enables you to have access to your PA infrastructure, and then the apps, if you have configured your FQDN and targets and IP subnet targets, they get programmed to the connector, and this enables you the users to access the private apps. So here right now the interfaces are getting initialized. In this phase we have a mix certificate, we have controller connectivity, and then it's kind of authenticating. Now if you carefully look at this, the uptime is 2 minutes. So I booted up the connector, it's 2 minutes since I booted up, and it has managed to initialize the interface, it has managed to get a controller connectivity, it has managed to get a mix certificate. Okay, this timeline might vary, and sometimes it may not connect depending on how you have uh, positioned your connector inside your inside your location, either it's a data center or cloud platform. And if there is any kind of firewall, or which is trying to prevent these connections to get established, we may not be able to progress beyond the interface initialization. So in depth, how to troubleshoot this, what IPs to be allowed, what not to be allowed, we will discuss this more during the troubleshooting session. So this is just a heads up for the participants to understand that by default this is what is expected, and if this doesn't happen, something is preventing it, and why it is happening, what is required to enable it, we'll discuss it tomorrow. So I've once we finish this controller connection, and when the claim is in progress, you will be logged out of the connector, and then the default credentials will no longer work for you. So this is an indication that the connector has onboarded successfully into the it has established a connection with PA controller, and it has connected to the Prisma Access tenant, and we no longer have access inside the connector, and we need to shift our operations, monitoring, and troubleshooting everything to the Starter Cloud Manager, which gives you or enables you as a customer to operate it in terms of configuring the targets, as well as to do some basic troubleshooting. And it is expected it's expected to work unless there is some kind of an issue in the network that is preventing the tunnels to get come up, or the tunnels to be configured, for example. Right, so the default expected behavior is the next phase is the tunnel is to configuration to be applied. The nearest location, the ZTNA tunnel terminator ZTT would be orchestrated by the Prisma Access PA controller, and connector would anchor itself to its assigned service IP of the ZTT. Okay, so these are the next step, which is transparent to the user. As far as user is concerned, we don't need to uh, do any manual work in this, any creation of tunnels or secrets or configuration to be applied. So once the connector is fully onboarded with the tunnels built up, so if you notice here, the time says 23 minutes. Okay, so the 23 minutes is the time it took for the first connector to come on board, because when it comes up, it spins up the resources in PA infrastructure, and it takes this much amount of time for the connector onboarding to be complete. We have all the certificates, we have controller connection, we have the tunnel buildup. So this can be seen from the Starter Cloud Manager, from the tools available in Starter Cloud Manager. Okay, so This is the completion of the configuration of the connector, and the tunnel is up. The configuration is completed, and we are good to go now with using this connector for accessing our private apps. And we can configure our FQDN and IP target, IP subnet or wildcard targets from the Strata Cloud Manager. Now, from the user perspective, when you look at this connector from the Strata Cloud Manager, this is very important to look for. So when the connector has a PA controller connection, this would be up. If not, it would be down. And if the tunnel is being created, this also will be, initially it will be down for first 23 minutes, and which are, for in my case, which the example I've shown you, and after that it comes up. This is the location at which it is connected. Because I'm based in Singapore, the connector has been, the nearest location for the connector was AP Southeast, which is Singapore, Southeast 1. And the tunnel has been established, anchored to the ZTT in the PA location AP Southeast. This is the version of the connector. This is the block assigned from the connector block pool. This is internally utilized by connector. This subnet is not exposed to the data center. Okay, and these are the three vital tools available in SCM. This is for the text support file. This is for packet capture from the interfaces, and this is for doing some basic ping, TCP ping, NS lookup from the UI, Strata Cloud Manager UI. All these are remotely executed from the Strata Cloud Manager to the connector, inside the connector. So when you launch this tool and you provide the inputs, it will execute it inside the connector and give you the result. Okay, so this is the icon. The hand icon is for tech support file, and if you click on it, and then you'll get a pop-up window. You click on generate tech support. Usually it doesn't indicate to you what it is doing, so have some patience, and probably you can close this and then look into it after a minute or two. Then the file will be available for you to download by clicking on complete. Okay, so this completes this generates the tech support file for you. Okay, so I have a sample tech support file over here. We will deep dive into this file tomorrow during the troubleshooting session. Okay, and if, for example, the dump overview output, if you type here, I'm not sure if it is. Charles, can you see the text? Is it
I was going to ask if you can change the font size a little bigger.
okay? I'm not sure it's possible. Is this better? The view?
Not really.
Okay.
If you view option, I would think you'd have a zoom in option available to you.
Yeah, on view, it's a tech support file, so it's expected to read like this. You understand? So tomorrow I will have a bigger font for to show you the details about it. But what is important is when you click on this, for example, the dump overview, we have the output available for you to see. The tunnel is up, and then the interface is up. Okay, so I will try to have this file in a readable font for tomorrow's session. But for now, just understand that we have a tech support file which captures all the information from the connector and gives you an output. And the most important item people look for is in this is a service IP, to which they need to allow in the firewall the UDP 500 and 4500 for the tunnel to get established if the tunnel is down, because they don't know which IP to which the tunnel has to be established. So if you look at, if you search for the service link, uh, so here this is the IP. Okay, I think this is this fine, Charles? The Zoom?
Yep, I was trying to get my mouse over to mute. Yeah, that's much better. Thank you. Yes.
Okay, so this is the service link status summary. So here, this is a tunnel. The tunnel. This is the local IP of the connector, and this is the PA location IP in AP Southeast to which the tunnel is built up. So if you have the connector onboarded and the tunnel doesn't come up, and you have a firewall which needs to allow the IPsec traffic, ESP traffic, or UDP 500 for IK and 4500 if you're doing a NAT traversal, then you need to allow this IP address for your tunnel to come up. Okay, and it can be determined using this command I mentioned, dump service link summary all. Okay, So this one, and then the overview. Let me show it again. So this one gives you the summary of the connect. I already showed you in the previous slide. So this gives you, further information about it. Okay, it's a very useful file, information text support file, and it helps you to troubleshoot your problems or understand what's going on in your ZTNA connector, and then share it with us. And it would accelerate the speed with which we can try to solve your problem if you have a real time issue happening in your connector. Okay. So with this, one last thing, the application. So we'll have a short break for 10 minutes, and then we will see how to onboard an app. So far, just to recap, we had an introduction about the ZTNA solution. We looked into the architecture, the various components. We discussed about the two types of deployment, one arm and two arm, depending upon the use case. And then we discussed about the journey of the connector onboarding and how it is done, step by step. We saw how it gets created, where to get the templates, where how we configure, how it gets itself onboarded, how it establish connection with the PA controller, and then how the tunnel gets created. So next step would be the actual application, private apps. We need to provide access through this connector. We will discuss about it in detail, and after that we'll have a short demo to show you how it looks like in a lab environment, and then we'll take it up from there, the remaining topics of the day. Okay.
This has been fantastic, and I got to give mad props to Chintaka doing a fantastic job answering the questions in chat. We're seeing a lot of communication going in there. Yeah, no, this is absolutely brilliant. I have us at roughly 28 after the hour, so let's shoot for 38 after the hour. We'll get started up again, everyone. I'll put out a 10-minute prompt, and yeah, we'll see everybody back in about 10 minutes. Thank you very much.
Thank you very much. Thank you, Chintaka, for answering all the questions.
Agreed.